Hello guys, you're welcome to this channel. Writing their whole level exam including NECO, GCE and all that. So might be useful for any other person including teachers that want to get one or two balancing in terms of the topics we're going to treat. So now we are taking a topic in mathematics and it is circle geometry. So and then we know that we have plane geometry and we have circle geometry. So we need a little knowledge of the plane geometry in circle geometry as well. But first thing we need to know is we need to understand the property of a circle before we could understand in details how the circle geometry works. So and there are various theorems that we're going to combine together in solving varieties of questions on circle theorem. So firstly, the topic is circle theorem, or let's say circle geometry. So if you want to talk about this in details and you want it to at least make it be easier for you to understand, you need to understand what the circle is and some properties. You might believe you know that, but there are some certain things you might be placing wrongly. So but let us discuss it all together. If you are beyond that, good. If you are going to achieve one or two things, it's fine. So now let's take a look at the circle. Okay, don't mind this, that is not a perfect circle, but let's manage this. So this is a circle now. So circle is just like the locus of a point. Locus means the path of a given point, equidistance from a fixed point. Now this is a center of the circle. So an example is if you're meant to move around the tree in such a way that you're always moving 2 meters away from the tree, so you could not move beyond 2 meters. That means by the time you're moving around, you form a circle. So which means the distance between you and the tree will happen to be the center of that circle. So the distance between you and the tree every time should be 2 meters, which is called radius. So the distance from the center of a circle to any part of the circle is called the radius. Now you see, this part of the circle is called the circumference. The complete line, the complete curve that binds the circle is called the circumference. So everything around here is called the circumference. So here we have R, which is the radius. R is the radius of the circle, and then the whole bounding length is called the circumference. So you can also call it the perimeter of the circle. So that's, since it is the distance around the circle, is the perimeter, or you call it the circumference. So let's just write it, circumference. So these are one of the things you need to know as far as the circle is concerned. So now don't forget that the radius could be drawn from the center to any point on the circle, and at the same time if you draw two radius, which means you have divided the circle into two, and that forms a diameter. So if I draw two radius, so which means combining another radius here, so it means I've divided the circle into two parts. So the first part is called the semicircle and the other part is called the semicircle as well. Meanwhile, the line that cuts the circle is called a chord, but this particular chord divides the circle into two equal parts, so we give it a special name. We call it diameter. So if I label this A, B, that is the line from A to B, is diameter. So y O is the center of the circle, y R is the radius. So which means AB, to represent the line, is a what? Is a diameter. So, and from the explanation I've made, you should know that a diameter is equals to 2 radius. So which means you have 2 radius in the diameter. Now, how does the diameter different from other chords? So let me draw another circle here. So now this is the center of the circle. Now a diameter will pass through the center of the circle, while a normal chord will pass through every other part of the circle apart from the center. So which means a diameter will divide the circle into two equal parts. A chord will divide the circle into what? Two unequal parts. So the bigger part will be called a major segment. I think, let me put it this way. A diameter, we divide the circle into two halves, so which is called semicircle. Meanwhile, a chord, we divide the circle, an ordinary chord, which is not a diameter, we divide the circle into major segments and minor segments. So the whole space here up there is called the segment, but a major segment because it's bigger. Then the one down is also a segment, but called a minor segment because it's smaller. So we have this, the whole space here, to be what a major segment. Major segment. So then we have this to be what? Minor segment. Okay. So then this line AB here will be just be a chord. It's just a chord. It will be called a chord. Yeah. So meanwhile, diameter is also a chord, but I think I've made my explanation clear about that. So now we have to dive into all the things we need to know about the circle. So don't mind me. I would love to use the slide alone. So that is it. Okay, I haven't understand that. We need to also understand that when you have this, a circle and the center, there is possibility of drawing your two radius like this. So when you draw your two radius like this, you have an angle between your two radius. So, and then the angle is two types. So this is one radius, this is another radius. Now look at the difference between these two radius drawn and this chord or the diameter is just like these ones form angles. So now the angles are two types. One is definitely smaller, while other is what? Bigger. So if you look at this, is the bigger angle. Mostly they call it a reflex angle, because angles that are reflex are always greater than 180. Don't forget that a straight line forms 180 degree. So if a straight line is 180 degree, so bending the line this way, if you bend the line this way, that is a straight line broken into two, or let's say bent in this way. So this angle will now be greater than 180, while this will be less than 180. So which means you have a reflex angle here, reflex angle at the center here, and at the same time you have angle smaller than 180, and the angle smaller than 180 could also be less than 90. So you can either have an obtuse angle here or an acute angle. So acute angles are less than 90. Meanwhile, obtuse angles are greater than 90 but less than 180. Are we getting it? So we need to have this idea from the plane geometry so we can apply it here as well. So now we have these could be acute if the angle is less than 90. Then it could be obtuse if it is greater than 90 but less than 180. However, this is always a reflex. So even if I turn the triangle like this, the biggest side, which is greater than 180, is a reflex angle. So now, apart from talking about the angles, there is one special thing I want to talk about in this type of diagram. Okay, let me get rid of this so that it can make it clearer. So now, drawing another circle to explain that. If I have this is a circle now. So let me just have to draw it so it will be a little bit clearer. So I have this circle. So then this is the center of the circle. Then I draw the two radius, which I've explained what the angles are. So now I have divided the circle into two parts as well. So the two parts is going to be called sectors and not segments. I think you'll be able to see the difference between a sector and a segment. So a circle is divided into segments when it is divided by a curve. Now, when the two radius have angles between them, that means you have divided the circle into a sector. So, however, there is a bigger sector containing the reflex angle, and there is a smaller sector containing the acute or the obtuse angle, depending on the values of the angle. So now, this will be called a sector, but a minor sector. Minor sector. Meanwhile, the bigger part will be called the major sector. So which means you should know that sectors are always bounded by angles. So minor sector is always bounded by angles that could be obtuse or acute. Meanwhile, the major sector is always a reflex angle. I think we understand this. Yeah, so that will be easy. So now if I stretch this to be a diameter, like to get a diameter is more or less like you make the radius like this. So spreading them up, that's when you have a diameter. So which means the both angle up and down is 180. So which means angle on a straight line is 180. So that shows that the total angle around in the circle is going to be 360 degrees, since you have a 180 in the first segment and you have 180 in the down segment. That is if it is divided by diameter. So then you have 360 as a sum of angle in the circle. So now we understand that. That's another property. I think I've talked about sector, segments, the angles, the chord. So I think we need to go into arc now. So now I'm gonna use this same diagram to explain arc. Arc is just a very simple concept. So now this is the circle we're talking about. Now part of the circumference, I call the whole distance, the bound of the circle, circumference. So now part of the circumference, if I call it out, so like from here right to here, is an arc. Meanwhile, this is also an arc. So an arc is just like cutting the part from the circumference. So that is an arc. However, you can have a major arc and you can have a minor arc. So just like the major is bigger, the minor is smaller. So this is the major arc, this is the minor arc. So which means the two radius plus the arc makes a sector. The same thing happens here, just like the angles are different. So that is a minor arc, that is a major arc. So I think we all know what an arc is now. So drawing this out, let's say A to B. So let me just try to use a certain marker. So like A to B. So drawing that out, B and A. So this is an arc, a minor arc. So meanwhile the bigger part is a major arc. So now let's look at another property that we need to know that is very, very compulsory, like in understanding the circle theorems. So now if I have a circle, okay, this is a circle. Now any line that passes through the circle that does not stay within the circle, when diameter and chord divide the circle, they are both within the circle. So now let's talk about the line that passes through the circle like this, either dividing the circle into two equal parts or not. So far it's not within the circle, so AB will be called a secant. A secant. So AB is called secant. So that is the line that divides the circle into two parts, or let's say the line that passed through the circle and is not within the circle, so it's called the secant. However, if I bring this line down, I can keep bringing down the line until probably the line just gets to this point or moves out of the circle. So once that's happened, I think I'll be having something like this. Yeah, it shows that the line is now outside of the circle but touching the circle a little bit. So then the line AB will become a tangent. So you call it a tangent. So that is the line that touches the circle from external points is called the tangent. Okay? So that is called a tangent. So we can say that AB is a tangent. So that shows AB is a tangent. So we understand all this property when it comes to a circle. So we have just finished discussing the properties of a circle, or things we need to know about a circle. So now let's move in. Okay, apart from the area of the circle, so we don't really need that in circle theory. So that is based on plane geometry, or let's say plane shapes, talking about their areas and circumference or the perimeter of the shape. So that is based on plane shapes, talking about plane shapes. So okay, we might need to use that as well. So we know that area of the circle, that's the how wide the inside of a circle is, how wide it is the area. So and that area is calculated using pi r squared. So area is pi r squared. So and then the perimeter, which is the distance round the circle, which is called the circumference c, is 2 pi r. So where r is the radius, I think we know. So and the area of the circle can also be given a separate formula, a different one. So area could be pi d squared over 4. So which, if you simplify this, you will still get pi r squared. So these are the properties of circles. So when we start stating theorems, it will be easier for us to understand what we mean by those theorems. So now let's talk about the first theorem that we'll have to discuss under the circle. However, theorem numbers are not meant to be remembered, they are just used for references. So if I call a theorem theorem 1 here, so which means it could be theorem 25 in wherever, maybe a textbook, but you don't need to remember the theorem number, you just have to understand what it's saying. So how we have to arrange the theorems here from 1, so how we call it theorem 1, so you might find it to be theorem 23 in any textbook. So now let's move on. Talking about the circle theorem, so let's talk about the theorem. I will start with a theorem which I call theorem 1. So just like I said, the theorem number, they are just for references, you don't have to remember them. So now this theorem says that a line drawn from the center of a circle to bisect a chord which is not a diameter, and the word bisect means is dividing the chord into 2 equal parts or 2 equal lengths. So the line drawn from the center of a circle to bisect a chord which is not a diameter, you know, diameter actually pass through the center itself. So then, I mean, it passes through the center and divide the circle into 2 equal parts. Meanwhile, every other chord does not pass through the center. So the line drawn from the center of a circle to bisect a chord which is not a diameter is at right angle to the chord. And when they say right angle, so right angle is just like when you draw something like this, perfect L shape. So and then the angle between those two lines is 90. So that is why they call it a right angle. So 90 degree is a right angle. So now let's go to that in diagram, and I state again, the line drawn from the center of a circle to bisect a chord which is not a diameter is at right angle to the chord. So which means if I have a circle now, then I have a chord. This chord is not actually a diameter. So now AB, then you have the center of the circle here. So if any line is drawn from this center to touch this chord, that means it has divided this chord into 2 equal parts. And at the same time, this line would be at right angle to this chord. That's what the theorem is trying to talk about. So now, which means AB. So at this point where the line touches the chord, I can put it as point M. So AB, which is the full length of the chord, is equals to 2 times MB or AM, whichever one. So because AM is equals to NB, AM is equals to NB. Okay, because they are 2 equal lines, because they are the line coming from the center bisects the chord into 2, so it can be 2 times MB or 2 times AM is still the same. Now, how do we use this to solve questions? So I would love to treat the theorem. So after treating the theorem, we will look at types of questions that could be hard on it. So and then we move to the next theorem. Okay. So now looking at this, we have the theorem interpreted in diagram, and you could prove this by construction, but here we're not going to prove by construction. So now let's look at a question that has to do with this. Okay, welcome back. The question is also here. So the question says calculate the length of a chord in a circle of radius 5 centimeter, which is at 3 centimeter away from the center of the circle. So looking at what we have just said, we can interpret that into diagram. So before we then solve it. So we're told that the chord is inside the circle. So this is the circle. So and then you have the chord. We are actually looking for the length of the chord, let's say AB. So any letter could be used, it could be XY. So now we're told that the radius of the circle, which the radius can be drawn from any point, from the center of the circle to any point. So I can always decide to join it here. Okay. And at the same time, we're told that the chord is at distance of 3 centimeters away from the center of the circle. So bringing that down here, so you have 3 centimeters here, and you have 5 centimeters here, which is the radius of the circle. So we are looking at this, and we also know from this theorem that this line drawn from the center of the circle to bisect the chord is always at right angle. So which means we have a right angle here. So having a right angle here shows that we have made a right angle triangle out of this question. So and that is it. So here is 5, here is 3, and here would be x. Okay, so in order to solve for x, and the rule that binds the right angle triangle is Pythagoras theorem, which says that the hypotenuse squared, so that is 5 squared, is equals to opposite square. So you can take 3 of x to be opposite. So that's 3 squared plus x squared. So we just have to solve for x here. So we have 25 is equal to 9 plus x squared. So bringing 9 here, you have 25 minus 9. So that gives us 16 equals x squared. So we are actually looking for x, not x squared. So we take the square root of both sides. So the square root of both sides would give, okay, check it out. So the square root of both sides is going to give us 4 equals to x. So which means the distance from here to here is 4. So don't forget the question asked us to calculate the length of the chord. So the length of half of the chord is 4. So therefore, length of the chord is equals to what? 2 times 4. Don't forget I told you the whole length of the chord is same thing as 2 times the length from here to here, since it is 2 equal parts. So, and varieties of question could come, no other question could come apart from probably, instead of looking for the length of the chord here, you might be given the length of the chord to find the distance between the chord and the center, just to find the radius of the circle. So all you need about this theorem is just the Pythagoras theorem. So if you understand this Pythagoras theorem, that's solving of right angle triangle with when you're given 2 sides of a right angle triangle, to find the third side, you use the Pythagoras theorem. So the longest side is the hypotenuse. So every other side could be opposite or adjacent depending on which angle you're using as reference. So if the angle is here, we don't need the angle here actually. So you can take anyone to be opposite or adjacent. So and then you solve for whatever you want to solve for. So now that is that on that theorem. So I think I have to treat another theorem now. So we treat one more theorem. So then we continue from there in the next class. Okay. So now let's move to the next theorem. Okay, I think I have to get rid of this. Don't mind me. Okay, let's make use of this slide. Good. So now we want to solve another theorem. So let's call that theorem 2. So for theorem 2, we can just state this, that the theorem 2 states that the angle subtended, you will say when angle is subtended from the center of the circle or at the center of the circle, is always twice the angle that comes from the circumference, or that's subtended at the circumference. So you know what the circumference is now. You know what the center of the circle is. So the angle that comes from the center of the circle is always twice the one that comes from the circumference. So now the angle that comes from the circumference should be behind the angle that comes from the center before the theorem could work. Now, let me give you a typical example of what I mean. If I draw a circle here, good. So then I have this. So angle that comes from the center is this. Are you getting it now? So this angle is angle theta and it comes from the center. So let's label OAB. So which means we have angle OAB as the angle from center. And however, I told you we have two angles at the center here, so you still have the reflex one. So you can call that reflex angle, that is AOB rather. You have to take it AOB. So which means the middle letter is where the angle falls, AOB. So that is reflex angle AOB. Okay. So now having this, those two are the angles subtended at the center. Agreed? But just that this one is reflex, this one is maybe obtuse or acute. So now having this, let us get rid of this. If I have decided to bring another angle from the circumference like this, something like this. Look at this. The angle that comes from the circumference is this, so let's label that X. Now this angle is actually behind this angle theta. So which means the theorem is trying to tell us that this is equals to theta. So and then the reflex here, we could call it alpha. So this is equals to alpha. So now, and this angle X is actually coming from the circumference, falling behind the angle theta. But it is actually at the front of angle alpha. So we cannot say that angle alpha is 2 times of X, because X is facing it, like angle facing each other oppositely. But X is behind theta because theta is not facing X. So theta will be 2 times of X. So that is what the theorem is trying to tell us. So angle AOB, don't forget that is not a reflex angle, that's theta, which is equals to theta, must also be equals to 2x. So that states the angle subtended at the center of the circle is twice the one subtended at the circumference, is twice of this. So now there are more complex diagrams that could cause confusion. So let us take, for instance, the diagram is not like this. The diagram could be in any other form. So let's look at this. Now, if I have this is the center of the circle, then I have something like this. Are you there? So then I also have something like this. Now I have a reflex angle here. I have the acute or obtuse. So let's give them the usual symbol, theta and alpha. So we can also make use of this kind of labeling. So, but let's just agree with this short way of identifying the angles. So let this be angle X and let this be angle Y. So you should know that theta is equals to 2x from the previous explanation. Why? Because x is behind theta. Now x is opposite to alpha. So which of the angle comes from the circumference? 2 angle comes from the circumference, y and x. 2 angle comes from the center, theta and alpha. So if theta and alpha comes from the center and x and y comes from the circumference, so theta is 2 times of x because x is behind theta and is opposite of alpha. Now, which angle will now be behind alpha, and that is y. So which means alpha is 2y. Why? Because alpha is behind y. Behind alpha, sorry, y is behind alpha. So and then it's not opposite. Meanwhile, y is opposite to theta, so we cannot say theta is 2y. So what we would say is that alpha is 2y because y is not opposite of alpha. Instead, it is behind alpha. So let us just solve a question to explain that. So now, if I have this kind of diagram, so then I have this and I have this. Good. So if I call this angle 60 degree and I want to find this angle y and I want to find this angle x. So it is quite easy to find them. So now when you're solving circle theorem question, you need to state the reason for whatever you do. Take for instance, now I know that the remaining angle here should be 300 y. So because at this angle O, you understand the sum of angle at a point or sum of angle in a circle should give us 360 degree. So how is it 300? I told you if you add these and these together, that is angle at a point. So you can say reflex angle, if this is O, so you call it AOB, must be equals to okay, reflex angle AOB plus 60 degree must be equals to 360 degrees. So because they are angle at a point, so at the end of the day, your reflex angle AOB is going to be what? 300 degrees. So that is why this is 300. So now, like the previous explanation, you know that 60 is 2 times of this because x is behind 60. So which means 60 degree is 2x. And the circle theorem, you have to state your reason. So angle at center is 2 times 1 at circumference. You just have to look for a way to shorten whatever reason you want to put. So then, which means x would be 30 degree. Agreed? So now, then the next is try to solve for y. So you can also say 300 degree is 2y. Using the same reason, you just have to repeat the reason. So then y will be 150 degree. So this is what we have. To subscribe to this channel and make sure you share this video to those who eventually needs it and those who will benefit from it. Thanks for watching.